Hi everybody, welcome to the iATL. We've got another webinar and this one's really interesting today. We're going to be doing how do we actually add cellular V2X and DSRC to your intersections. Today we've got Bryan Mulligan sitting with me. He's standing in for Walt Townsend today. So, you know, we had a major step up, so thanks Walt for dropping us, but we've got a great representative as Bryan, who's joining us today on this session. So before we start this session, we're going to cut over to Jessica, who's got a bunch of house rules for us. So over to you, Jessica.
Hey everyone, welcome back again to another Applied Information webinar. As always, we're going to encourage you guys to go ahead and click speaker view on that right upper hand corner. That's going to give you guys the best visibility into everything we're going to cover today. Per usual, we're going to do an interactive Q&A as we go along. So if you guys will send your questions into the Q&A icon down here at the bottom, and if you guys would like to ask live, you can put that request into me, but otherwise just type it in and we will get to that. And then we are going to be posting this recording to our YouTube channel and our Applied Information training channel if you guys need to leave early or want to share after this.
Awesome, thanks so much, Jessica. So, you know, what we wanted to do today was we've got a couple of different topics that we're going to be talking about. The first one is, you know, this whole lab and what we did here. And then we're going to go and actually see some of this technology in action in the field. And then we're going to go do a little bit of a walk around here to go into some more detail. And, you know, we'll close off with some of the closing topics. So, you know, the first thing, Bryan, why did we actually create the iATL, the Infrastructure Automotive Technology Laboratory, in terms of adding DSRC and CV2X to intersections?
Yeah, thanks, Pete. Thanks for having me on today. I think that what I'm going to do is just describe it in the focus of the practical business of making your infrastructure a connected vehicle infrastructure. Now we've all, you know, heard, just imagine if, just, you know, wait one day we're going to have this, and, you know, one day the future will be better and so forth. And that's fine. That's the vision that created connected vehicles. But we're at the point now where we actually have to deploy this in practice. And I'd just like to say welcome to our friends in Europe who I know are watching this. And we've got some folks from China, South Africa, various places around the world, part of the 5GA family and our friends and family all over the world. And so we got to the point now where it's really practical. What does a DSRC radio look like, the active elements, and how do we deploy it in the field? And so in the context of that we're the practical guys who've been deploying connected vehicle technology now for a number of years. And it's got beyond the theory to the practice. So we're going to show you in really practical terms how this laboratory contributes, because there are all kinds of different traffic controllers and they all send out information slightly differently. There are all sorts of different radios, current radios, future radios, and so forth. And they all work slightly differently. And so this lab is part of the business of what we say, get this technology out of the parking lot and let's go play in the traffic. Let's get it deployed in practice. And this lab is a key part of that.
So, you know, the lab, we're talking about how we actually integrate to, you know, all these different traffic controllers and things like that behind us. Talk us through also compatibility testing. What is being done here? Well,
there's compatibility testing happens at a number of different levels. And so the one is that the radios need to be compatible. And the second is that the applications need to be compatible. Thirdly, the infrastructure feeds need to be compatible. So I don't want to make it too complicated because those were really topics of separate webinars. But what I'd like to do is maybe just show you a couple of things that we can do here. And when it comes to talking about radios, these are the actual radios that are in play here. So this one this is a DSRC radio. This one over here is a cellular V2X radio. So when we're actually talking about the radios, we're talking about modules that contain some electronics that transmit radio signals. Now, people are used to seeing much bigger devices up on the up at the top of the poles. We're going to show you what's in some of those devices and some of those boxes. But when we actually talk about the radios, you're talking about relatively small, inexpensive things. And so we're going to talk about some of the current radios and some of the future radios. But this little show and tell gives you an idea how practical it is to deploy multiple radios and not get all hung up about this radio versus this radio. We're going to show you a bit later how we actually make the thing that goes on the pole have multiple slots. So you can have one of these radios, two of these radios, or future radios as well, so that you can future-proof your infrastructure.
So those radios, I mean, those chips are so tiny, but why is there such a massive box when we see these things on top of the pole?
There's a printed circuit board in all of these radios that contain the radio module. They also contain a radio processor that contain power supplies. And interestingly enough, the antenna have to be certain distances apart. So something about the size of the box is actually just to do with the antennas. And we can talk about all of these in more detail, probably beyond the scope of what we're doing today, where we're just showing how you set about getting started. And what we're going to try and reduce it right at the end to the 3 key takeaways. Irrespective, we're not selling today. What we do is just explaining the principles. Hopefully, if you choose to do these kind of radios, you'll choose to work with applied information. But it's not essential. The other manufacturers produce great technologies, but the underlying principles of what the radios look like and how they work is the same, and how you set about managing and future-proofing your infrastructure and so forth.
But you show these little radios, and you've obviously got a lot of experience of working with different types of radios. How easy is it to swap out? Let's say DSRC changes to DSRC 2.0.
Correct.
How hard is it to actually swap out one of those?
Well, as it happens, there are 2 little screws over here which secure it, and there's a plug at the bottom. It's called a PCI Express socket. And so this just clips in. And so it's an inexpensive, easy thing to do to change out the radios. And I think that that's something that's, as we've been struggling, quite frankly, in the infrastructure side to get widespread adoption of different radios, because it's presented to our customers as a very big decision to make. And what we and others are doing is saying, no, it's actually a much smaller decision, provided you do pluggable radios that you can upgrade in the future. This is the way you can actually deploy with confidence, because you're not fixed on a particular kind of, you don't have to pick a winner and consequently a loser. And there's both on the cellular V2X direct side, there are new iterations, 5G NR and so forth coming. On the DSRC, there are new versions of DSRC 2.0 coming about. And on the infrastructure side, we don't want to have to be pinned down to one or the other. And that's going to be some of the key principles we're going to show you in the field, how we set about deploying these technologies in practice.
So when we go out and do a deployment of DSRC, CV2X, people are going to go put in a box. And in the traffic industry, when they put in a box in the field, what they do is they expect that thing to work for the next 20 years. Does this give them the confidence that, that the devices are going to continue to evolve as auto manufacturers and other people are changing with the times? Because I get a new cell phone every year. I have a brand new cell phone every week. Now, I'm a geek. I like digital things, and I get something new, and that's got new chipsets and all the rest. Do I have to replace the whole box in the field, or is it quite a simple process?
It is a simple process, and we just have to accept that in the transportation industry, we've got various different kinds of customers. There's early adopters who want to deploy new cabinets, new controllers, and so forth. There's sort of the middle of the road who are not quite prepared to be on the bleeding edge of technology. And then there's some folks, partially through budget considerations and partly through the nature of the industry, who are very conservative and are running 10 and 15-year-old traffic controllers. And so this is the reality of the connected vehicle landscape, and that's why we're talking about adding these radios to existing technology, to existing infrastructure, and that's what we show you how that works. And earlier this morning we drove around and did a little, shot a little video out in the streets here in Alpharetta, Georgia, to show you how some of this is deployed in practice. So maybe we could do that. There's no sound or no narrative on this thing, so I'm going to talk over this video so you'll see some of the things that we're talking. Peter will stop and start it as we go. Unrehearsed, so what could possibly go wrong?
So what I'm going to do is I'm going to switch over to the video that we've got over here, and we're going to play this, and everybody will be able to see what we're seeing.
Before you start, Pete, and so what we just to set it up, and so what we're going to see, we're not selling a particular product or anything in this video. What we're doing is we're just showing that can be a user interface in a car that might be on the onboard dash, it might be on your phone, it might be connected to the controls of the vehicles to brake the car automatically. It all doesn't matter. The point being is connected vehicles have an interface in the car. And this one, what's particularly interesting is that it actually can talk to you through your ears. So we'll let it roll and show you some of the... Now, I'm not going to focus on applications. This drive this morning was actually to go and have a look at one of the cabinets out in the street. So let's roll this video and have a look. So what we're seeing here is a countdown timer, which there's a red light in front of us just outside the iATL. And this shows...
Get ready for green.
Get ready for green. Before the light turns green. And that's actually a very interesting application which allows you to pay attention and get going. And each of these traffic lights that we're going to come across in turn displays the status of the light on your smartphone, and it also communicates various alerts and alarms to your ears. There's some interesting studies being done at the moment about how to manage the human interface to a connected vehicle system. That's not part of what we're going to talk about today. That's probably the topic of a second webinar. But all these different kinds of traffic lights, that one had a flashing yellow arrow, left turns, some of them got protected left turns. This one ahead, interestingly enough, which is not active, but it's a protected right turn. This is, obviously you see a prohibited left turn and so forth. This has got is a simpler intersection. We're going to turn left here. The intersection we're going to go and have a look at is just up the road here. Something interesting is going to happen when we go around this corner, by the way, is for those of you who are interested in the kind of applications, there's a school beacon around the corner here. And what it does is that through the TIM message set, the travel information message, it sends a message to the car that there's a test beacon, and then it tells you if you're speeding in that school zone. Now, that's something for the car manufacturer to decide whether he automatically wants to slow the car down or not. We're in the business of equipping the infrastructure with the different kinds of radios. And essentially, there are 3 or 4 kinds of radios. This is a red light running. And you'll see that this is where this cabinet is that we're going to have a look at, where we've got 3 kinds. In fact, in this one, we've actually got 4 kinds of radios. We added cellular V2X direct, as we call it, which is a line of sight radio. Then we've got DSRC, which is the dedicated short-range communication. We've got cellular V2N, which is the network radios. And we've also actually got Wi-Fi radios, which we install in some places, just in case the spectrum for these other radios is taken away. So what you're seeing here is the radio box that's on the pole. Now, you can decide as an end user where you want to mount the radio box. A number of people have mounted the radio box right at the top of the pole, so you need a bucket track to maintain the radio. We thought that we'd prefer to have an option where you can maintain the radio, especially as we use pluggable radios, so that you can access this from a ladder without a bucket track. And in doing that, you don't have to have a lane closure in the city in order to be able to maintain the radio. So that's a key thing for you as a city to think about, is whether you want the radio at the top of the poles or accessible without a bucket track. Now, if you've got large spaces where you can have a bucket track and you've got bucket tracks on as part of your fleet, then it might not be a big issue for you. But a number of cities don't have space to put a bucket track in a congested area, and that's where it's very attractive to have a maintainable system that's maintainable without a bucket track. So that's how you mount the radios on the pole. Further above the radio is the antenna. Now, we chose to, in this embodiment, is to have the radio separate from the antenna separate from the radio. And this means you can add cellular V2X direct and DSRC with having only inert, there's no electronics, there's no LEDs, there's nothing to look at, there's nothing to maintain at the top of the pole where you need a bucket track. And the business of whether you need one antenna, two antennas, four antennas, whether you can use a diplex. So there's lots of interesting things to be resolved depending on what the FCC rules and decides in their notice of proposed rulemaking. I'm not going to go over that in a lot of detail. I'll answer any questions specifically if people want to know what we're doing in that area. But this is the hardware in the field that is used to add cellular V2X direct and DSRC to a traffic intersection, which is the topic of what we're talking about today. So if
while we're on this, I'm just noticing that there's it's not very noticeable. Now I saw that they're black on this pole, and that's one of the big things that most cities, are trying to beautify everything. Can you talk a little bit about the decision to make the antennas even black?
Sure. It was actually quite an interesting story because Alpharetta here have a beautiful streetscape strategy and regulation, and all the light masts are all black here in Alpharetta. And so when we talked to them and were awarded this contract to add these radios to, they thought it really important to them that it all look the same. And so consequently, there are little details here that are really neat. One is the antenna are black. It was a custom order and it made a huge difference. All the hardware is black, and even the banded strapping is black. And so that makes it visually as unobtrusive as possible. And so you can do a lot of things to, if you're sensitive about the aesthetics of what this looks like. And obviously we focused right in here on this, but it's all quite unobtrusive. You have to look quite hard to see which pole has actually got these radios fitted to them. So it's only a box about a foot square, which is again keyed just in the same way as your traffic cabinet. So these are things that your maintenance technicians will be used to doing. This is the traffic cabinet. What we'll do is we'll just talk about something we add to the traffic cabinet. And this is called an RSU processor. Now, on a separate webinar, when we talk a lot about applications, one of the key things that Alpharetta wanted as far as an application in this cabinet was emergency vehicle preemption. And so what this is the RSU processor that does a whole bunch of things, but the key thing it does is it runs the emergency vehicle preemption rules based on the signals received by the radios. And it's got some test buttons and so forth, so you can actually test the interface with the traffic controller to make sure that when you calling preempt number 1, 2, or 3, or 4, whatever your rule calls, that the traffic controller behaves correctly. And so this is why for some of these applications we put equipment in the cabinet. But if you hashtag get ready for Ford, you're only interested in the connected vehicle applications of cellular V2X direct and cellular and DSRC and so forth, then you don't actually have to put anything in the cabinet at all.
What is that below the unit? So you've got the top unit. For the people that don't know, what is that, the black box below the AI unit?
That's actually the traffic controller. That's the controller. Then there are many brands of traffic controller in the United States that turn the lights red, yellow, and green. And what we do is we interface with that little flat pizza box that's above the traffic controller. And in fact, I'll talk later, we've got a couple of different form factors. You can see this one over here is a smaller form factor with exactly the same functionality. It's electronically equivalent. But this is something that will do monitoring as well as emergency vehicle preemption. Now, there's some of the traffic controller manufacturers are looking to do emergency vehicle preemption inside the traffic controller, and that's fine. And so in that case, you wouldn't need, and if you're happy with the monitoring provided by that traffic controller, there's lots of options to make a system that suits your needs. And when we conclude, we'll just really reiterate the 3 most important things as we see it. So that's a little selector switch which shows, and there's some LEDs, which show the diagnostics of what's happening with your connected vehicle system at ground level, as opposed to having to climb up to the top of the pole and try and see what LEDs are doing. This is where the wiring connects. You can, if you just pause there, there's a number of traffic controllers that actually have hardwired preempt inputs. That's the panel that you see at the bottom there, where it actually is wired to the traffic controller. So this system works with multiple brands of traffic controller because they've all got a standardized input of how you actually bring inputs wired into the traffic controller, so-called preempt panel.
And that seems to be kind of the recommended practice. Majority of the places is most people are using a physical wired interface.
It's just what the industry is used to. And it's not for me to say, in fact, it's a hugely important point, is that, people accuse me of, all you're trying to do is sell your product. All you're trying to do is focus on whatever features you've got that can keep other people out. Applied information actually doesn't work like that. Interestingly enough, what we do is we go around and with our channel partners, our distributors, and we talk to customers, we talk to them continuously about what they're comfortable with. And the business of hardwired preempt inputs have been around in the traffic business for many years. The traffic engineers are comfortable with them. They're comfortable how they've been tested. They're comfortable with the experience. Now, the fact is that we could achieve a preempt input by putting in an Ethernet cable and calling a preempt input over a signal over a protocol is probably how the future is going to unfold. But it's not for us to say to our customers, no, you've got to do it like this. What we do is we expose them and bring along the technology in a way that they're comfortable with. And most customers at the moment want hardwired inputs. So we do both. And we say, choose this one you like. There's a configuration that you set that says whether it goes out over an Ethernet cable or whether it goes out of hardwire wires, or both.
Okay, so let's go on here.
So what you just see is some additional wires at the back here. This is the back of the unit, which has got a number of inputs. And you can see different wires. So in fact, if we just stop there, Pete, perhaps there'll be a couple of things to talk about when it comes to the wiring. One is to know when the lights are turning green. Is the traffic controller responding correctly to your preempt request over your connected vehicle system? And then what we also believe is an important part of managing a connected vehicle system is to be able to monitor the status and health so that you know when something's gone wrong. And all of these units have a small battery inside so that they can actually communicate back home and say, hey, I've lost power to this traffic intersection and so forth. So the whole topic of monitoring status and health is probably the topic of another webinar all by itself.
Absolutely, and if anyone wants to see some of these other webinars, go to our YouTube page. And while we're talking about that right now, while I'm back on, if you've got any questions, what we are doing today is we are taking questions in the middle, and basically it will have breaks where we're going to answer a bunch of your questions. So please write down your questions, put it in the Q&A chat, and Jessica is going to stop us when we get a chance to break up. So all right, Bryan, there's one or two tiny little things left on this video that I wanted to go through that you showcased to us.
All right, so let's just stop there. This is the top of the cabinet. And so you saw two antennae at the top of the pole for cellular V2X direct, as well as for DSRC. What you see over here is another two antenna on the cabinet. And the one on the left, in fact, is for 4G LTE. That's the cellular V2N component. So that's the cellular to network component, which is part of cellular V2X. And we use that to do send a whole bunch of messages and so forth. The one on the right, interestingly enough, is an unlicensed 900 megahertz radio, so-called Wi-Fi radio. And when we first developed this product, which was before cellular V2X direct, and while DSRC was under a big argument about which was going to be adopted, and there was a real threat that perhaps the FCC weren't going to provide any spectrum for connected vehicle direct, then what we did is we said, for the cost of an additional radio, they're absolutely inexpensive, let's cover our bases. And so this is a Wi-Fi radio that provides direct line of sight communications with the fire trucks, ambulances, and buses and so forth, as belts and braces with the other radios. And what we do is we send the same messages over all the radios, and then we just process whichever message arrives first. So it's actually a truly redundant radio set, which has actually proved very effective for the critical life-saving applications of preemption.
Great, yeah, that's pretty much the end of this little walk around that we did. So that's absolutely great. All right, so there's obviously a number of different topics and things like that. I want to just check, Jessica, do we have any questions? Yes, I believe we do have a question. Let's go for it.
All right, so someone is asking, Bryan, could you please go into a little more detail when an agency would need the box inside of the cabinet?
Yes. The question is, what do you want it to do? And so we believe that in day one, what we call day one applications, and a day one application is something like emergency vehicle preemption, transit signal priority, and so forth. So that's where the box inside the cabinet comes in, is that it immediately does these applications irrespective of what your traffic controller is. So it's a new traffic controller, it's an old traffic controller, it doesn't matter. We can make them all work. We can make the cellular V2N, the network radio work, and for example, deliver Travel Safely, which is the app that you saw us driving around with. So there's a number of things that you can do with the box in the cabinet that you can't do with just the box and the pole. And so it makes some difference in price, but really not a lot compared with the idea of when you don't put all the radios in. Now you're having to bet what the future is, and when, let's say you're a city and the mayor says, let's say I only put in cellular V2X direct, or only DSRC, and the mayor says to you as the traffic engineer, so what's it going to do? And you say, oh no, nothing. But wait, one day in the future, it's going to do a lot, because one day there are going to be cars with DSRC radios, or there's cars with cellular V2X radios. We think it's an easier thing for the mayor to grasp, to say, what does it do? Well, it gets my paramedics, uses connected vehicle technology to get my paramedics to citizens in need while bringing everybody else safely to a halt. It makes my buses work better. It delivers better health outcomes for underprivileged communities. But it's ready for Ford, it's ready for Toyota, and it's ready for whoever and whatever comes in the future, because we've got all the radios covered.
Perfect. Thanks, Brian. That was a great answer. I think, Jessica, I think you've probably got another question over there. Do you want to hand over to her?
Yes. Brian, so they're asking, are you saying that even if we already built out a DSRC network, all we would need to do is simply switch out the radios? Could you expand?
This is where you get into manufacturer-specific issues. And so if you've built out a DSRC network with a manufacturer who believed that DSRC was going to win and everybody else was going to lose, then no, you've got to change out the radios, because those radios are not physically built with pluggable radios. And so that's where you'd need to go back to your manufacturer and say, what is your upgrade program look like for new radios? And I'm not being shy. When we look at applied information, we say, what's our upgrade program for DSRC to be able to DSRC advanced or 2.0, whatever that we're talking about on the DSR side? Well, what you do is you actually unplug this and you plug a new one of these in. Well, how much does that cost? It costs a couple of $100. How do you physically do that? Do I need a bucket truck? No, you don't. And so that's where and this also depends on your relationship with your radio supplier. And I'm not knocking one person or another, but it's unfolding that there are two categories of providers in this space. One, folks who sell radios. And I'm not, people who sell radios, that's great. You want to buy DSR3 radios and put them on pole? Good for you, you've bought radios. But if you want to be a solutions provider who's going to say, yes, but I want to buy radios that I want you to warrant are going to comply with standards that haven't been thought of yet, and FCC band plans that haven't been resolved yet, and I need you to guarantee me a future-proof path. That gets you into the category of solutions providers who use all kinds of different radios. I mean, we don't make these radios, bluntly. I mean, we're not a radio supplier. This is modules that are made by very clever folks who make radios, and we use them as part of a solution, not just as a radio supplier. And if you're quite confident that you've got a really good handle on this, and you want to be either a systems integrator or a city, that you want to manage your own assets and have your own radios and so forth, that you feel quite comfortable from that, well then my principles don't really resonate with you, because you decided that you know what the future is.
But one thing that you can do, based on, in other words, if you guys have an existing DSRC radio network and you want to add applied information stuff, you can put one of these boxes into your cabinets, and we interface to every DSRC and every CV2X radio supplier. So what is really important is this will work and do emergency vehicle preemption. It does connected vehicles over the smartphone app. and it can interface to Lear, Comsignia, all the different. We have projects all over the country where we've interfaced to everybody.
That is actually a great point, Pete, which so I made my answer probably more complicated than it should be. In other words, if you've got a DSRC existing network and you want to add the applications that we do by putting the box, which in our case is putting the box in the cabinet, go right ahead. You don't need to replace the DSRC system that you already have. We'll reuse your existing DSRC system.
And we'll run them simultaneously. So
Absolutely.
you can use a smartphone, or you can use basically the
Anybody's
DSRC.
OBU? Yeah.
Anyone's OBU. So we very much, and that's why we built this whole iATL lab, was so that we could test and work with it. And we've done various projects all over the country. University of Alabama, great test case where we deployed originally 85 DSRC radios and cellular V2X network to actually test out all this technology.
Yes, and in fact, it's quite funny because that it gets quite complex quite quickly. So one of the things that we did is we just provided a warranty that it'll work as we say it'll work with your radios, and if it doesn't work like we say it's going to work, we'll give you your money back. So there's we do try before you buy. We'll prove it all out at the iATL, and then get going, and it'll work exactly like we say it's going to work because it's all tested out here.
So Bryan, why don't we do a little bit of a walk around, unless Jessica, do you have any more questions there? Okay, yeah. Let's do a little walk around just so we can show everybody what we're talking about, and just give me 2 seconds, as maybe you want to talk for a couple of seconds there, Bryan, as I bring up the camera.
Sure, I think that what we're going to do is seeing is believing. There's two kinds of facts in the technology business, as I like to say. Ones you've been told and ones you've seen. And so what we're going to do is to show you physically how these pluggable radios work, what's inside the boxes that you've seen on the pole and so forth. Because this is all being deployed from coast to coast, in fact, beyond coast to coast, because we're actually deploying in Hawaii as we speak. And so this is all the practical future of connected vehicles and how you add cellular V2X and DSRC to your intersections. So what I'm going to do is just show you over here in the lab here, there's one of those boxes that you saw on the pole, and you just have a look at what's inside it. We took the lid off so that you can see that right in here there's space for 1, 2, 3 of these radio modules. And so, what you do is you see that, obviously I'm not going to do this because this is powered up, but you just plug in these additional radios. And so this is, a radio slot for cellular V2X. Sorry, production, all good? Are we all good? Yeah, sorry. All good. Bill and Mike behind the board here. And so this is the cellular V2X module. This is where the DSRC module goes. And this is where the future 5G NR or DSRC 2.0. And this allows you to have both forward compatibility as well as backwards compatibility. So this is the radio module as we've done it with a conventional traffic cabinet key, so it can be maintained by the traffic cabinet. And what we see over here is the antenna, and the antenna discussion is quite interesting. There's multiple solutions of antenna that are largely dependent on what the FCC rules. We're expecting it later on in the summer. DSRC, cellular V2X, which band is used for which, and whether we can do a splitter in the cabinet or whether we have to do a splitter on the pole with separate antenna. If you come over here, is something kind of interesting. This is some functional art that we've shown before, and these are different kinds of radios, just to show how we really focus on making module relationships. We call this the evolution of radios, because these are just radios that we've used in the last 7 or 8 years, going from 2G to 3G. There's a cellular network kind of radios. This is a Wi-Fi radio and unlicensed, where it would look like the band was going away completely and we still need to have connected vehicles working for our emergency vehicles. This is 4G LTE, which is very widely used now. These are the little modules that we see. This is a cellular V2X module, and this is a DSRC module. Now, what we just did is we just got different brands of DSRC modules, and these are the ones we've elected to use in production, and so forth. And there's some really good plug fests and compatibility testing that's gone on with the different DSRC modules, and likewise with cellular V2X at the radio level. And so what we do is, because we do over there software update to all our devices, what that means is that we can make sure that at the application layer, these things are all compatible. And then the future is going to be 5G. There's lots of exciting stuff going on with 5G, including 5G NR, new radio, which is a side link radio, like cellular V2X or DSRC, but that'll be included in the 5G chipsets. And so what you'll have there is the ability to be able to do both network as well as direct out of one chipset. And in fact, even more complicated is and exciting is the concept of edge computing, where in fact a bunch of processing is going to be done at the tower or at the edge of the cellular network, where you can get ultra low latency and ultra capacity for all kinds of new technologies like teleoperated driving and many other applications, where you can use the processing power of the cloud and bring it right down to the edge, so you can get really high bandwidths and very low latency.
I've got a question for you. I'm seeing various different things behind you. Is there the ability of adding cellular V2X and DSRC to non-traffic signal controller devices like what we see behind you?
Absolutely. You've got to get the idea that a radio is a hugely complicated thing. Now, while we were pioneering this, yes, it was hugely complicated, and yes, you had map files, and yes, you had all kinds of complexity, which was very difficult to deal with. But as we're turning it into production, the question is, do you want one radio? Or do you want two radios? Or do you want three radios? So any of these radios can be plugged into a school beacon device. And these are different kinds of school beacon devices, or a flood warning system and so forth. So yes, what we do is provide a family of radios that can be plugged into anything. They all get fed with data by an Ethernet port. The interesting thing is that we're showing is that the cellular V2N, which is the network part of cellular V2X. Don't forget, cellular V2X is two components. It's got the direct and it's got the network part to it. And so what that gives us the capability for many devices like school beacons and speed warning ahead and school buses and all sorts of applications work very well over the network, because you don't require the instantaneous latency that you get with the direct. You don't need them to perhaps talk directly to the car, but the car can get the information of, is the school beacon on, over the network. And so that's where we're seeing really exciting potential to make your all your products, all that you deployed, your whole infrastructure, intelligent and part of a connected vehicle network. Interestingly enough, for those of you who want two kinds of facts, the ones you've seen and the ones you've been told, the Dutch in the Netherlands have done a very interesting project called Talking Traffic. You can just Google that, fairly which we can forward you some links to some of their material, and where they deployed direct radios, but they also deployed network radios. And they've found it very successful to get smartphone users to use the network radios to give them changeable speed limit, traffic conditions, queue stopped ahead, many applications they've done very successfully over network, to the extent that in the Netherlands they're focusing on the network side of cellular V2X and going slower on the direct side.
Great. That's absolutely great. Let's take a seat and see if there are any questions. All right, Jessica, we got any questions there?
Yes, we have one. They're asking, is the management interface to view the DSRC radio on glance? How are the map messages set up for DSRC radios? Is it similar to how we set up Travel Safely?
Correct. So at the next level of detail, how that's done, the map messages that are sent out by the DSRC radios are generated in a tool which was developed by the US DOT. And so that's a very similar tool to how Travel Safely map messages are generated. And they end up being downloaded into the traffic controller, into the DSRC radio. This is typically how it's done. And then broadcast out by the DSRC radio. What we found is there's some limitations in that map file to do with displaying multiple lanes, to displaying and to set up alarming and so forth. But we support them directly, so that your motor car with a DSRC OBU would receive a map message exactly like it expected. And as all things, the way we do it is we productize that. So when we sell you a DSRC radio, it comes with map messages, so you don't need to hire a consultant to do it separately. It's included as part of the offering that you get from our distributors.
And maybe just to add to that, one of the important things that we do beforehand is we do ask you for your intersection phasing, as well as all the timing and your preemption outputs. So that what we can do beforehand is when you send us that information, we configure all these map files so that everything comes out when we deliver it to you, that it's basically plug it in and everything's configured and works. And I think that's a very, very critical thing is, as Bryan was talking about earlier, what we do is we try provide a system that you're not trying to be a system integrator yourself as a city. You're basically going in and you've got all the blocks, everything's working, that you can see everything work right away.
Okay, this next one is just a short one. Can you guys reference which Dutch company that was again in the Netherlands?
Yes, the Rijkswaterstaat, which is the Dutch government. And what they did is actually have a very interesting project where they actually spent a lot of money, some private, some public, and put together a whole back end with multiple mobile network operators and achieved very low latencies, very clever design, very effective, scalable thing. Peter, how many users do they have there? A couple of million?
It was millions.
Yeah. A couple of million users on a very scalable system, and found it very, so that was the Rijkswaterstaat, which is the government.
And you can go Rijkswaterstaat, we'll text it to you, but Rijkswaterstaat.nl. And that's
traffic,
and it's talkingtraffic.nl as well. That's instead of .com.nl for the Netherlands. Great. Jessica, any more?
Yes. We have someone asking, Bryan, how do you address the overlap in spectrum in the 5.9 band of DSRC and CV2X radios, and are they simultaneously interoperable?
And I'm going to answer that with a yes and yes again. The FCC is currently busy with a notice of proposed rulemaking and a band plan where in all likelihood they're going to provide the upper 20 megahertz in the band to cellular V2X. There's a question about where they move DSRC to or what they're going to do. The reason why I say yes is how a traffic controller works. And so what it does is a traffic controller in principle sends out messages. it's less important how it receives messages, but I'll come to that in a little bit. But how it sends up messages are the map and the spat message. The spat is the signal phase and timing. The map is the intersection geometry. And it sends out both of those. It sends out the map message about once a second. It sends out the spat message 10 times a second. But it only takes a millisecond or two to actually transmit the messages. So just to be 100% right, here I've got a cellular V2X transmitter, and here's I've got a DSRC transmitter, and this is genuine. These are the real things. So what you do is, under software control, you transmit the one, and then you transmit the other. You don't actually broadcast them at the same time. So you transmit like this, every 10th of a second. So you're actually not transmitting at the same time. And what you'll do is that you'll, to what extent there is any interference from intersections, further down the road, you can have broadcast schemes where they never transmit at the same time. And that's the key way of making sure, no matter what happens with the radios, they're never going to interfere. And we're never going to interfere with a new kind of radio, because we'll just make them transmit at different times.
So does that mean that you could have a vehicle that had, let's say Toyota decides to do DSRC and Ford decides to do CV2X, both of them can actually receive the information at the same time?
That is correct. And when I say at the same time, I'm talking about, at practical terms, within the same 1 or 2 or 3 milliseconds. So they can both receive them at the same time. But actually what we can do, and this is something that lies in the future depending on what the FCC rule, is that you can not only broadcast like this, but for the rest of the time, you're actually sitting listening. So 10 times a second, the cars are broadcasting basic safety messages. And this is a DSRC radio, and this is a cellular V2X radio. And let's say this receives from Toyota. Well, what we can do is we can transmit that out over a cellular, it's called rebroadcasting. And as we in NEMA, the National Electrical Manufacturers Association, have written some standards, we're advocating that we don't try and pretend that we're a car, but we package up a bunch of basic safety messages from this technology, and we rebroadcast it over this technology. And if you do that, we can provide a bridging, both for the current two technologies, but most importantly, I don't have a third hand, when the third technology comes about, and we're talking about 5G, NR, and so forth. Rebroadcast, I mean, some folks, I remember I was talking to some folks about this, they said, oh, but that's spectrally inefficient. It uses spectrum that could be used for something else. And I said, yeah, but the practical problem is we're not rebroadcasting anything. Let's not worry about in 10 years' time, when the spectrums are clogged because we're being inefficient, we'll be saving lives in the interim by using some of these techniques. And it's exactly the same way that the mobile network operators, some of them are turned down 2G, some of them are turning down 3G. Just imagine how spectrally efficient it would be if we forced all the mobile network operators to only use 4G. Well, it's just not practical. We end up with spectral inefficiencies as we deploy practically the stuff in the field.
So I wanted to just go over to some of the most important takeaways from today that we want to talk about, because we've spoken for almost an hour and we've heard a lot of different things. What are the key takeaways that everybody should be thinking about?
In my view, the cities and the counties and the states who's stepping into this world want to, point number one, really have to be focused on being future-proof. I'd love to say it was certain that DSRC was going to win out, or cellular V2X, but the reality is we just don't know. It's going to be temper dependent on what the auto companies decide to do. In fact, the auto innovators, the new trade association for the automobile companies, have just written to the US DOT and the FCC and said they're going to deploy 5 million motor vehicles in the next 5 years, I believe it is, of one or other technology. So they're committing to deploy, but it's going to be fought out by the auto companies. So let's, on the infrastructure side, not wait or bet or guess. Let's just expect that it might be both for a while, or all three for a while, and focus on that. So I would suggest, I mean, I'm not suggesting that you buy from Applied Information unless you want to, but what you should do, whoever your vendor is, or your solutions provider, ask them how they're going to solve that problem. And we've explained how we see the future with pluggable radios. It's possible that some other folks have got alternate solutions, and when that comes, this is America. We compete in the marketplace for the best solution.
Okay, so the pluggable radios making everything compatible and future-proof is the first takeaway. What would your second takeaway be?
The second takeaway is to consider and remember that cellular V2X encompasses two technologies. It encompasses a direct line of sight radio, and it encompasses a network radio. You have to consider that this is what the future looks like. To say that, oh no, but we're only going to have line of sight radios, and we're not going to have network radios because it's a pay-to-play thing. You have to pay. Now that's a political problem. Should you force people to provide free service? I don't have a dog in that fight. But the range and the effectiveness of smartphones and cellular technologies has just shown us that it's just going to be a force to be reckoned with vulnerable road users, with pedestrians, with cyclists, with scooters, with who knows what is in the future. We have to have cellular V2N as part of this discussion from the get-go, because otherwise you're just going to be left behind if you haven't figured out how to do what we call data exchange services for cellular network providers.
And the two technologies are actually complementary. I mean, that's the critical thing is, whether or not you receive a message over the cellular network or you receive it directly, you're going around a corner, you can still see around the corner by utilizing cellular.
We're just the practical guys who are just deploying this out in the field. So we don't try and sell you hard on this is better than this. We say, let's just show you how it works. Let's just show you what redundant radios look like. Let's just show you how this works. Come and have a look. Come and have a drive around. Come and see what we've done in different cities. And we're in over 600 cities right now, of folks who've actually realized that this is actually all for real. And so the third point, as we're running out of time, is the key thing of managing the status and health of these radios. To manage, for the folks who went early on spread spectrum radios and so forth, their own custom radio networks, they realized how difficult it was to maintain a radio system. And so we put a lot of effort into managing the status and health of the radios. And that's the third thing that I'd encourage you to ask your solutions provider about how are we going to manage the status and health and keep all of this running.
Yeah, I think that's a critical thing, because with everything, managing all of these different types of devices is a lot harder than everyone thinks. We've got about 1 minute left. Jessica, I want to just check if there are any questions. No? Perfect. So I just want to thank everybody for joining us, and I want to especially thank Bryan Mulligan for joining us today and talking to us about CV2X and DSRC and how to actually practically add that to your intersections. So,
and if I didn't bore everybody, then I'd love to have the opportunity at some future time to talk about applications, to talk about some of the more advanced issues and so forth. So if you want to send Jessica some questions or some thoughts of further complex issues, which we're going to distill down to 1 or 2 key points, I'd love to do that as well.
And we're definitely going to have this on YouTube, as Jessica said. So you guys will receive a link with YouTube and also our webinar channel. So, and please, Jessica is going to continue to send out great content for our next webinars as well. So please look forward to those and can't wait to speak to you guys again. Thanks so much. Bye-bye.